Hello, welcome. Today we're just going to practice simplifying. Remember, there's some things that with simplifying that we do and do not like. We do not like to have fractional exponents or radicals in the denominator. We similarly don't like to have binomials of either in the denominator. We like to cancel out everything that would cancel. So if I had x plus 4 times x plus 3 over x plus 4, I like to cancel out the x plus 4s. So that's really quickly a couple things on simplifying, but now let's get into some nitty-gritties. If I had something like this, 2 minus root 3, I don't like it because there's a radical in the denominator. So I'm going to multiply both the numerator and denominator by 2 plus root 3. That way, if I do my area model, I get a negative 2 root 3 and a positive 2 root 3 that cancel each other out. That's because these signs are opposite. 4, this gives me a 3. So my denominator becomes 4, negative 3. 4 minus 3, or just plain old 1 in this case. My numerator is 2 plus root 3. So please remember that if this had been a binomial in the numerator, you'd have to make another area model for your numerator. Something similar applies if I have 1 over 2 minus x to the 1/2. Oh, let me do 1 plus x to the 1/2 in the numerator. Again, this is the same as saying the square root of x. So I'm going to multiply by 2 plus x to the 1/2 on the numerator and on the denominator. I can make my area model for each part. In the numerator, I have 1 plus x to the 1/2, 2x to the 1/2. This gives me a 2, 2x to the 1/2, x to the 1/2, whole x. So my numerator is now x plus 3, x to the 1/2, plus 2. And my denominator, I'm going to get the middles to cancel. This is 4. This is negative x. So my denominator becomes 4 minus x. Sometimes we simplify by factoring. I'm going to make this really, really ugly. Times x plus 2 plus x plus 4 times x minus 3. And I'm going to stick this all over x plus 4. One thing you can do is you can break this apart into two different fractions, in which case I would take this side here. See, it's kind of faint. That'd be one fraction, and this would be my other fraction with a plus sign in between, and then I can cancel things out. The other way to do that, however, get rid of those, is to factor out a GCF. The GCF in this case happens to be x plus 4. If I pull out an x plus 4, I'm going to be left with, in this term, an additional x plus 4 and an x plus 2. Notice if I redistribute in, I get x plus 4 squared times x plus 2. Plus, when I pull out the x plus 4, I'm left with x minus 3. And that's going to go over x plus 4. These can cancel because they're identical, binomials. And then I'm left with x plus 4 times x plus 2 plus x minus 3. Here I can do my area models in my head to multiply that out. And then I can simplify and I get x squared plus 7x plus 5. And that would be a simplified version of this. Again, something else to consider. When simplified, if I had 25 to the 1/2, remember that's the same as the square root of 25, which is 5. 25 to the negative 1/2 is the same as 1 over 25 to the half, which again is 1 over the square root of 25, which is just plain 1/5. Also, please recall that you can do things like 8 to the 2/3. That means the cubed root of 8 squared. Cubed root of 8 is 2. 2 squared is 4. One more quick reminder is on factoring. Remember, you can factor with a GCF. That's pulling out the greatest thing they have in common. You always do that first. Another way to factor trinomials is the empty box thing. So if I had x squared plus 6x plus 5, I'm trying to find the outsides so that I get x squared in the top left, 5 in the bottom right, and these two add to be 6x. So in this case, it'd be x plus 5, x plus 1. You also have a difference of squares, anything in the form x squared minus y squared. And that factors into x plus y, x minus y. Remember, this needs to be a perfect square minus difference of squares. So if I had x to the 4th minus 4, this is a perfect square, and this is a perfect square. Square root of this is x squared, square root of this is 2. A parenthesis with each, one has a plus, one has a minus. Now let's go to cubes. X cubed minus y cubed. This is a difference of cubes. It factors into x minus y times x squared plus xy plus y squared. As opposed to x cubed plus y cubed, which would factor into x plus y, same as this one, x squared minus xy, opposite of that one, plus y squared. So if I had, let's say, x cubed minus 8, perfect cube, minus. So I'm going to be using this formula. Cubed root of x cubed is x, cubed root of 8 is 2, minus in between. Square him, multiply them, square him, opposite sign goes here, this is always a plus. Factored. Similar would apply with the plus. Then the finale is factoring by grouping. That's when you have 4 terms. X cubed plus 2x squared plus 4x plus 8. I pair them into 2's. I find the GCF. X squared. Oh, first I look for GCF in the whole thing. Don't forget, you always do that. X squared times x plus 2 when I pull out the GCF of x squared. Plus GCF here is 4, x plus 2. Lo and behold, those are the same, so I get x squared plus 4 times x plus 2. Factored. And that is your video for today.